I try to help your guy to finish all of the lab up until lab number 6. On the tech show, the major will be doing the lab. That means you're able to understand the circuit, to complete the Excel, make sure it passed. And also your program will be ready. That's almost done. Only thing is when you build it and you run the test, make sure it passed. Okay? And I believe very soon we can able to get that, the lab to be doing. But the key point is understand it. Today we will start with the DLAB06 and backward, okay? From now on, you will be learning most of the IC, not really like flip-flop. You can get too many things, too many flip-flop, but this just the one IC. For example, you're learning about the counter, and you understand the counter will be counting, just a number from 0 up to any number you want. Or they can be counting down, okay, from any number down to 0. So basically, we already talking about normally the counter, you can get a binary counter or BCD counter. So you have to understand what it means for the binary counter or the BCD counter. Binary counter means if you get a 4-bit, easy to recognize you're looking on the output of the counter. For this counter, you get QA, QB, QC, QD. That means 4 flip-flop. Okay. And they can be counting from 0 to 15 using the formula 2 power of n. N means number 4. 2 power of 4 means 16. 16 state. However, if you're talking about the decimal, they will be only going from 0 to 15. The thing is you start at the 0. And the BCD will be counting from 0 to number 9. BCD means the binary code decimal. That means they binary, but they working exactly the decimal. And the decimal cannot be get any number higher than 9. And also the counter, they either can be counting up or either counting down. Okay? So also on the number of the counter, you can see this is a 74, 193. 193 means the binary counter. And when you get the number in even, they will be a BCD counter. That means 74, 192. Or you can see you can get 74, 161, and you know that binary. 74, 160, even number. So that will be BCD, okay? Or 191 or 192, okay? So now, only thing when you're looking into 74, 193 now, we need to know how many functions this counter can do. You know for sure, first thing is you can clear the counter. clear the counter that on pin number 14 here. What active? What active for the clear?
Active high.
Active high.
Active high. What that means?
It means you need a logic 1 to clear.
Exactly. Active high, that means 1 they will be clear, 0 they not. Okay? And the second function will be load pin 11. Load means active low, right? If load equals 0, then the QA will be equal input 15, A right here, and QB pin 2 equal B pin number 1, and output 6 equal pin number 10, and output 7 will be equal pin number 9. That means you can loading any data to the output of the counter. Okay? The thing is, sometimes you don't want to counting from 0 to any number. You want to counting from number 5. Then first thing you can loading output to number 5. Then you start counting. Then they will be 6, 7, 8, 9, whatever. Okay? That means loading. And we already know clear is a higher priority. That means when you want to clear, you cannot do anything else. Output have to be on 0. That's a higher. So that's why when I want to enter the data, I want you to enter don't care. Okay, now what that means when you enter don't care? Don't care only telling you in the binary they either 0 or 1. You enter 1 or 0 doesn't matter. But we need to say don't care the thing A. For example, for the clear test, you apply logic 1 to pin 14, and the output have to be 0. The rest of the input, load A or B or C or D, up or down, I say don't care. That means when you apply logic 1 to pin 14 and they not 0 at the output, then only thing you can check will be to pin 14 for logic 1. If they do logic 1, that means the IC not working. Do not try to check any pin 11, 50, 15, or 1, or 10, or 9, or pin 4, or pin 5. The thing is we don't care. Okay? And the second priority, that will be the load. If you want to loading data from input U2 to output U2, first thing, clear must be 0. The thing is clear equal 1, you cannot load it. Okay? Second thing, 11, load must be 0. Then you can apply pin A, pin B, pin C, pin D. And the output QA, QB, QC, QD will be equal A, B, C, D. That will be loaded. And now if you want to counting up, okay, and in order to counting up, then that will be make sure pin clear must be 0. If you get 1, they cannot count. And also pin load must be 1. Okay, do not loading anything. So that's why A or B or C or D, yeah, you're not loading. So that's why A or B or C or D doesn't matter. And the clock will be go to the up pin number 5. However, the required pin number 4 down must be 1. So the counter will be count 0 to 15 and keep going. 0 to 15, 0 to 15. Okay, forever.
Hey, Mr. Pham,
Yeah,
I pretty much understand, but I got a question for you. On U2, they don't really have a bar over up or down, and they don't have a bubble. So how do you know which one is 1 and which one is 0?
okay, the two table telling you, or the timing will be telling you. Okay, that means when you're looking into the timing.
Yeah, because I'm saying just looking at the circuit right there, you can't tell.
Right, exactly.
Okay, okay, that answered my question. Thank you.
Yeah, if you want it, call out. If you want to know, either on the data book, they get the function for this IC and also the timing diagram.
Yeah, I got that part. It was just that I got that part. It was just that if you look at the circuit in itself,
Right.
and you look at
you cannot tell.
you look at U2, you cannot tell.
Right. I said anything confusing, anything you not quite understand or anything else you want, go ahead and ask. I will be helping you to understand.
But the main thing is when you see something like this as a technician, nobody's going to be helping you. So you need to just look at the data sheet then.
Normally, at working, it's a different. Okay. Sometimes they already telling you what input and what they want to make it output.
Okay.
Okay.
Right.
Otherwise, it's hard to do. But understand doing at school is harder than at work.
Right. Okay. Thank you.
Mr. Pham,
Yeah.
got a question for you. Let's say for counting up, okay, we said, clear, that pin has to be 0,
Yeah.
low is 1, and then pin 4 is 1, pin 5 is the positive clock.
Right.
Now, what about, how do you set, from what number counting from and to? Is that on the input ABCD?
Now, if you want to count from ABCD, right?
Well, that's what I'm saying.
Count from number 2.
Yeah, let's say count from number 2.
Okay, first thing you need load number 2 first.
You what? Number 2 first?
Yeah, you're loading number 2 to QA, QB, QC, QD.
So therefore, I mean, usually it's 0s and 1s. So does that mean we use the hex? So it's like
right.
Number 2, it will be 0, 0,
1, 0, 0, 1, right? Now, number 2, 0, 0, I, 0, 2.
And then if you wanted to count from 0, you would just clear
right.
first.
So basically, depending on what number you want to start counting.
And then what about you said you can count from, like here, you're asking us from 0 to 15.
Right.
How do you set the second number 15?
Right.
Where do you put that in?
Normally, counter will be count 0 to 15.
The counter usually is 0 to 15.
Yeah.
Okay.
And also, they already telling you, you can counting from any number. Like from 7 to 15, okay.
Right.
Then you loading 7. Then you start counting.
Okay. And then once you get to 15, then
go back 0.
0, 0, and then go to 1 again, right?
Right.
Okay. All right. Good.
Okay, now the other thing is output. You can get your output. That means number 12 and number 13. Number 12 means CO carry out active load. So normally when they counting, you're looking in pin number 12 here. What logic you think?
1.
1. Perfect. They only going low when something happens. Okay? If you're looking at a timing diagram, then you can see when the output go up to 1, 1, 1, 1, then the CO will be go low. Okay, just a short time, then they go back to high. Just a negative positive, telling the people counter already reached to 50. Okay, that will be, you can say that happen in your watch. Okay, in your watch. Okay, you get a counter for an hour. So the hour will be counting. Okay, when they count up to 60 minutes, so that output will be going low. Go to the circuitry for minute counting. So now the counting will be start counting. Okay, and after 60 minutes, they go to a 60 second. So they get a hand shaking. That's why, you know, the output CO will be let the people know when you're looking the output, see it going low. Then you know they complete counting.
Hey, Mr. Pham,
Yeah.
so did you say that was a negative or positive pulse?
Negative.
Negative.
Normally they high. Only thing is they go low when the output reach 1, 1, 1, 1. But they get low for a few seconds. They go up microsecond, and they go up again.
Is it one cycle of the clock that they stay low, or is it longer than that?
No, that's a small one. Depending on after that, then they after they count up to 1, 1, 1, 1, 1, 1, right?
Right.
Then got what happened? They go back 0.
Yes, and then it goes high again.
Right.
Okay.
Exactly.
I know we've been over this, Mr. Pham. So that pulse is the pulse is like tall, and then it goes back low, which is the shorter part. It's hard to say. You got to draw it. Could you just draw a negative and a positive pulse?
Yeah, you can draw it. However, you have to draw, make sure output have to be on 1.
It is on the timing diagram if you
Exactly.
Google the IC.
Yeah.
On the timing, when we're talking about timing. Okay, however, now, if you want to test to make sure when you get QA1, QB1, QC1, QD1, and you get a pulse coming out, how do we make sure you see that pulse? I think after they go low and then they go back high.
What is the question?
The question is, how do we test output CO?
With an LED?
That means manual intervention, right? You can connect LED here. Normally you see it high, right? Light on. When they get into the negative pulse, and the LED will be turned off.
Mr. Pham, when you
That's
say
how the lab volts work, huh?
I don't see where you're pointing to.
No, what I'm saying is, how do we test this output?
he's talking about pin 12 and 13 on U2.
Okay, you can see, I can go here, at this point right here. You can see normally they high,
Right.
they only going low here.
Mm-hmm.
Then they high again. How do we test it?
Like Catherine said, with the LED, right?
That's what she said, LED, but that's the
Oh,
manual intervention.
Okay.
hey, Mr. Fan, is it possible to see that with the oscilloscope?
Yeah,
And
you can use an oscilloscope. However, that oscilloscope must be started. Okay, that means when they see the point coming out, they catch it, and you can look into that. Must be started oscilloscope.
oh, storage.
Yeah, started. In
Okay.
our school, we get a oscilloscope for 4 channel. That's started. Okay.
Can we buy DMM?
No, DMM, how do we see that?
Let's see it. No.
No way. If you're testing by manual, then okay, you can connect the LED there. Normally they hide. Only thing is when they turn it off, that means you get a negative point coming out. Okay. Now, same thing on this bio. You can get the same thing, right? They will be low.
Negative pulse.
Yeah, same thing. On the reach when they reach 0. Let's count down. Okay. However, when you get the first one, then the second one must be 1. Okay. That means every time you see only 1, not both. When you're counting up, then this 13 will be all the time will be high. When you're counting down, pin number 12 carry over all the time will be high. That means you get only 1 negative pulse at a time.
Okay. So what you're saying is if 12 has a pulse, then 13 would have 1.
Right. They
And
both.
if 13 has the pulse, then 12 is 1.
Exactly.
Okay.
And Mr. Pham,
Yeah.
is it correct that in this circuitry, PC5 will only go high during one of those negative pulses from pin 12 or 13?
Exactly.
Okay,
That's what-
thank you.
That's what we want to testing for automatic.
Yes, sir.
Okay.
Okay.
That means before pin number 5 to be high, we already reset it, clear that, make sure they 0. So when they get the pulse coming out to the preset go low, Q must be 1. So that's
Okay.
why I'm looking pin number 5. If they 1, I know I get the pulse. If they
Right.
will be 0, that means no pulse coming out.
Okay, because that was going to be my answer to how you know pins 12 or 13 went low, was you could check PC5, right?
Exactly.
Okay, thank you.
I adding that to make the test automatically. You don't have to see, and you still know they working or not working.
Got it.
Yeah, you understand up to that point, you're really good. Okay, now I can tell you normally if you want to testing, then you can apply the clock right here. Keep going, not one clock. Okay? So that is telling you pin 3, pin 2, pin 6, pin 7. Also, they get a frequency coming out. Keep going. So normally you say, I want 10K. Okay? 10 kilohertz logic. In your generator, where you can get that signal. On your generator, you get only one output. Okay? And also you can get a sine wave, right? Square wave, triangle wave. However, how do we get this signal?
Isn't it just the square wave?
No. The thing is why square wave you can get a positive and negative.
Mm-hmm.
We don't want negative. We get a logic only 0 to 5.
Oh, okay.
Crystal?
No,
So
I'm
we
talking
check it.
about generator.
We check pin 4 and pin 5.
Where you connect your generator to get that's like the square wave. However, they only 0 to 5 volts. You cannot change the amplitude, but you can change any frequency you want. What output of the generator you supposed to connect to? Okay, you don't know, I tell you. In your generator, they get this output. TTL logic. That means look like you want the clock signal. Then you must be connected to the TTL logic output of the generator. They will be given to you the signal with the 0 up to 4 or 5 volt. That value cannot be changed. However, you can change any frequency you want. 1K, 2K, 10K, whatever. Okay? Then and you looking using scope to see at the output CO, you can see they go this way. No. You can see they will go this way. Okay, so basically that they get counting from 0 that to 15. Okay, and keep going. That means you can verify that negative positive. But that basically just a manual intervention. You have to see and decide right or wrong. not automatic. Now, when you're looking into the YouTube and you understand the clock will be positive, up, okay? That means you want the clock look like that. Positive. However, how come we're using negative? That means we're using the clock look like that one.
I don't know. Is it falling edge triggered or something?
No. I will tell you. Okay? They want positive, how come we apply negative? Okay, now you understand here.
You got a NAND gate there.
Exactly.
So, and what happens is when it goes through, the NAND will flip that negative clock over to a positive clock.
Right. If you try to test only IC, only this IC, nothing else, then you have to apply positive. However, in this circuitry here, I using pin number 7, PA07, right here, to control up or down. If I put a 1 here, I want up. Now you see, if a 1 here, they go to the NAND, they will be 0. And now the negative pulse go to the NAND. Basically, you adding to positive pole. They revert it. So that's why you get positive clock. However, also you get a 1 right here. You go to the NAND, they will be 0 right here. Okay, 0 right here. The clock can go in here, but cannot go into this NAND. 0 output here must be 1. So that's why to apply, we get the requirement. You go up, you get the clock here. And down must be 1. Okay, that's how this part of the circuitry working. So when you change up 1 here, okay, to 0, that will be telling you can get this must be 1. And now the clock will be go into pin number 4. Okay. Okay, so that is a part of the circuitry, how they working. Okay, then you can see on the left, the requirement we already telling you. I want to test the load data file A. Then I want to clear. Then I want to counting up 0 to 15 to 0. Number 5, I say I want to test the output CO. Number 6, I load data, I will be counting down. And finally, I test, make sure output BO, they working. Okay. Now, that's what they given to you. So basically, you have to answer this thing here. 1, 2, 3, up to 15. Okay. How many pin, whatever. You get any question to answer for this data here. By looking into the IC here, you're able to recognize 14 clear, 2 QB, 3 QA, or whatever.
No, we're good on that one.
Not big deal, right?
Yes.
Hey,
Yeah.
Mr. Pham, that one below, yeah. No, on the bottom. No, further down. Down, down, not up, down. No, you're going the wrong way.
You want me up or down?
I want to see the stuff that's on the bottom.
Bottom here, here,
Yeah, this part right here.
this part here,
Yeah,
this part here, okay? I just said, I want to load 0101. And you have to tell me what the input and output supposed to be. So from I understand, you want to load, clear must be,
0.
zero,
load have to be,
zero.
okay, 0101, 0101.
Yeah.
4, 5 down.
Okay.
Don't care.
Yeah. And that will be output 010.
No, no, QA has got to be 1.
Okay, go opposite.
Yeah.
Yeah,
It's
that's okay.
1010.
Yeah. That should be 1, 0, 1, 0.
Now, what about for CO and BO? They don't care?
Those will be 1.
Hey, Mr. Pham, you need to fix your screen so we can see the yeah. COBO.
Just about a minute. Right, this one, okay?
Yeah, right there.
Oh, don't care. Okay.
We don't do anything with the counting.
Okay.
But won't those be still held at 1?
You know, I had that same question because on the data sheet, isn't CO and BO high for load and clear?
Yeah, that's what I thought as well, because clear, even clear as an overriding asynchronous input, it says only the Q outputs are affected when you clear.
When you try to clear the IC, right?
Right.
We don't care about CO, BO.
Okay. Thank you.
Yeah.
So the data sheet is wrong?
No, that's not wrong.
So they are 1. We just don't care.
Right.
Okay.
We only care when they load.
Okay.
Okay. And the load 1010, same thing, right?
Mm-hmm.
Okay. Then when I say I want to clear, then you can say clear have to be 1.
And then the rest are all don't care.
Perfect. Okay. And the output here have to be 0,
0.
0, 0, 0. Okay. The rest will be don't care.
And COBO don't care.
Yeah, doesn't matter. That's the only thing we want. And now counting up. Clear must be,
0,
load must be,
1.
1.
down.
Care.
Don't care.
The thing is we're not loading, so we don't care.
Right.
Pin 4 and 5. Okay, pin 4 must be,
1.
5 must be
Positive clock.
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 Okay. And
Now,
basically,
Do we type the P/clock? Is that what we type there?
Yeah.
that means positive.
Right. Okay.
system giving you positive clock
Okay,
and underscore clock, that means negative.
right.
And this one you don't care.
So the output would be 0, 0, 0, 0 for counting up.
You mean the counting up?
Yeah, the output.
0, that means that you apply the clock, they have to be 1.
So it'd be 0, 0, 0, 1 then.
Yeah, 0, 0, 1. If you apply the clock, okay, then they will be 0, 0, 1, 0, 0, 2, right?
Okay, so
They keep one clock, they count 1. The reason I put a number 2 clear and guarantee before you start counting up, output will be 0. Then now you apply the clock, they go 1.
oh, okay.
Okay?
Yeah.
For count up and count down, what is COBO?
We don't care.
Oh, don't care as well?
Only thing is after they done for count up, now I care.
Oh, okay.
Make sure they get a negative positive.
All right. Okay.
Or count down the same thing. Make sure when they reach 0,
Mhm.
then we're supposed to get negative pulse from BO.
And for pin 4 and 5 on count down, you would just switch around, count up.
Yeah, the thing is the way we design the circuitry automatically. If the clock go to up, then down must be 1.
Mm-hmm.
And for this section, we're saying that the outputs for count up and count down, we don't care, or
Don't
for
care.
the Q outputs?
Don't care about what.
For counting up and counting down on this, just on
Right.
this
You
chart,
don't care about COBO.
but
He's talking about, Mr. Pham, he's talking about the outputs.
yeah, QA, QB, QC, QD.
They must be 0, 1, then 2, then 3, then 4, then 5. Depending on you apply the clock.
Oh, yeah. After clear, then it goes 0001, then
Right.
0002,
Eight,
0003.
Each one need 1 clock.
Right, but so on this chart, I would say that the Q outputs read 0001.
Now count up in here, you can enter 001 or whatever number. We don't care. So that's why on this one, we don't check it.
So QA, QB, QC, QD, we don't care what they are for count up on this chart.
Yeah, basically depending on, if you say after 0 in here, you say count up, they're supposed to be 0001.
Right.
They
And for
go-
counting,
They go to number 1.
right.
That's the correct answer.
Okay.
Okay, and count down. So now, before we counting down, we have to make sure the output have to be on 1. That's why you must be loading number 111, go to the output of the counter before you start counting down. That means you're loading pin number 15. Then when you apply, they will be go down to 14. And keep going down.
Hey, Mr. Pham, so
Yeah.
on this chart here, when do you use the positive pulse and the negative pulse? On what, number 5 and number 6 or what?
Yeah, I think he just wants it
Yet,
there.
when I say, when counting up to 1111, okay, then return to 0. That's why what happened to the CO, that's why you want to verify the negative positive. Only 1. When they reach on 1, that negative coming out. And that will be try to preset U number 4A. So the output pin number 5, now they must be 1.
Because pre was 0 then, right?
Yeah. The thing is when they're coming out negative, that preset the flip-flop.
And it's the same when the countdown from 0, 0,
Okay.
0, 0.
Exactly.
All right.
Make sure guarantee you get negative points coming out.
Okay.
Now, what is it here?
That's something you left from last time or whatever.
Oh, that
We've already done that part.
okay. Nothing to do with that.
Yeah, right.
Now, port A. So you understand you can enter the data to load, right? Load 0101 1010. Okay? Then you test for the clear. You know what data is supposed to be applied for port A. Then you start counting up. Okay? On the test for CO, I say enable. That means how much you understand when you see NA on that line.
CO NA.
NA means no answer, right?
Not able.
Not able.
What does
That only telling you on that test CO, you don't have to write to port A.
Non-applicable.
so you don't have to do anything.
Non-applicable, you
Yeah.
don't have to use it.
Right. You don't have to write to port A on that test. That's what that means. Okay.
Now, for this, what about the PA07? What's supposed to go in column PA07? Is it 1?
Be
Column
up or
PA07.
down. Yeah, you must be enter when up or down.
So what
You want to go up, that means what logic on PA pin 7?
Well, it's got that star beside it, which would be a low, but you said that make it a 1.
Right. Normally, in order to counting up, okay, and you understand the down must be 1. Up will be applied the clock. However, for this circuitry here, we already telling you, you want go up, then PA7 must be 1. The thing is you get a NAND gate. Okay? So that's why you have to understand that in order to complete this port A for counting up.
1 for row for the test 1, 2, was it number 4? I guess number 4 is 1. The rest it doesn't matter, right?
Number 4, you're talking about that number 4.
Count up, is that where you put the 1 for pin 7?
Okay,
Right.
now I can tell you. Okay, for that one.
Don't care, don't care, don't care.
Now this have to be
1.
1.
1.
So only when it's counting up, you have to do
Right.
Okay.
And down, that means you start counting down. They must be
0.
0.
Down is 0.
Now, but Mr. Pham, I understand what you guys are saying. All I'm saying is that symbol that you have there where it has U and then the star means active low.
right.
But in this case, you're saying for this particular assignment, you want up to be 1
Right.
because of the NAND gate.
Right.
But that symbol actually, it says up is active low and down is active high.
Right.
Okay, got it.
Normally, you're using the you typing, you cannot get the bar over. They have to take a lot of time to do that.
Okay.
Okay, now on that one.
This is where I'm getting stuck myself. I got
On
through
that
port.
one here,
Can't get port C.
You're doing good.
on that one here, I think you already know for the load, right?
Right.
You want output to be 0, right?
Mm-hmm.
Let's see. You want that to be A will be 0, 1, 0, 1.
One.
And the math data will be
0x05.
05.
math data, that is 0x05.
Right.
And the math data, they supposed to be 0, I, 0,
F.
F.
F. Okay?
And the peak off?
Now, on the peacock, what caused the problem if they fail? Then you're looking into the circuitry here. You want to load to write port A,
U2.
right here. Data 0, 0, 1, 0, 1. Then you want the load will be pin 11 have to be 0. Pin clear must be 1. No, 0. And the output will be 0, 1, 0, 1. So when they fail, what caused the problem?
U2.
U2. That only this guy. You apply input directly to this guy. And you measure the output directly here. If they're not working, U2, nothing else.
And when you manually load, you're not using the clock, so you're not using U1.
No, we do nothing with that. The thing is,
Right.
clock we don't care.
Right.
Okay?
So the peak off for the first one is U2.
Exactly. That we try to isolate it. Okay. So basically, you can say that will be U2. And the second one, same thing, right?
Right.
That will be same thing. The next one, that clear. Okay? That clear. And basically, you want output to be on 0, right? And
Right.
it will be same thing here, same thing here. Okay? Now, when you start counting up, so map data for the first one, okay? That is when they get a blue here, you don't have to write anything. However, when you counting up, the first one, what the peacock. That means we 0, we apply clock, they go to 1.
So it's
Okay.
U1 and U2?
Now I have to looking into here. Okay, when you counting up, so make sure you're able to get the clock, go to up, pin number 4 must be 1. So that will be cover this guy, right?
You
If
want
this guy not working, then counter is not working. Okay, so that's why in the peacock, they will be U1 and U2. That will be telling you, for example, I run the first one for the counting. They're supposed to count to number 1, but they're not. Then that's what you need to do is you have to, using your meter, to make sure here, okay, or using the scope, okay, make sure here you're able to get a negative, that positive clock. Okay, and the major right at this point here, you make sure you get logic 1. If you measure in at pin 3, you were supposed to get a clock. They not. Then you go back to pin number 1. Guarantee they must be logic 1. And with pin number 2, make sure you get negative clock. If you get 1 here, negative clock here, you cannot get a clock output. If 1A will be caught the problem. That is how to troubleshoot it. And after you get that, you measure U1, pin number 8 here, guarantee you get logic 1. If they not logic 1, then you have to go back here. Okay? Guarantee in here you must get 0, and in here you must get 1. Okay? And now during the counting, peak up not changing. Okay?
Hey, Mr. Pham, can I say one thing?
Yeah.
On the mass data on the clear, it should have been 0x1f, right?
Right.
Okay.
On that one here.
Yeah, 0x1f.
Why 1F?
Because you got that 1 bit at PC5.
Right. That's the thing you want to guarantee. This output here must be 0. The thing is, if you see the clear right here, this is clear at the logic 1. They go to the NAND and they tie together like inverter. So that's why you get 0 here. 0 here will be clear. This guy.
Mhm.
Make sure they be 0.
Mhm. When the input is clear, when the input is 0, active low, the output has got to be 0.
Right. Okay, so that we could go up to the pin, the test 20th.
So
You
that
can
is
test
0
the
times
CO.
0, is it, or 0 times 0, 1?
Okay, now, if you want test the CO here, okay, and we want to make sure COBO here, this pin here, they supposed to be 1, right? The thing is they already preset the flip-flop. However, my question here, what the math data here?
0x10.
0x10?
The
Oh.
answer will be 0x10. Why? The thing
Because
is
you're
you
only
want
interested in
to
PC5.
take only this guy. So that will be, don't care. I want to make sure this guy go 1. So that will be 0x10. And now, another one. P corp. What caused the problem? When you testing here, you want it to be a 1, and they not 1. What do you think the P corp should be?
U1, U2, and U4? Oh no, maybe all of them.
No, nothing to do with U1.
U2, U3, U4 then.
Exactly. That means you need guarantee you get negative port come out, right? Okay, and that will be 1. So that's why that will be negative here, and that's why you get negative here. And if you preset, they not go 1, U4. So the P corp will be U2, U3, U4. That's only telling you when you're looking into that, they failed this test. then you know how to do what to do. Okay, you can connect to the 4 o'clock to go. Then you can see this negative coming here. Okay, and also make sure you can measure here, you can get a 1. So same thing for the red. However, on this test here, I already doing for you. Okay. This is you must follow it. I'm talking only about counting up, counting down. Now, counting up, if you don't want to type in 16 tab, then you must be using the loop, doing 16 times. You must get along with that. Thing is, later on when you're testing the memory, they can be 1,000 tabs, 2,000 tabs. You don't want to sit there and typing 1,000 tabs, no way. That's why they must be using the loop. Okay? That will be telling you inside the loop. First thing, you have to say for integer I if j equal 1. If j less or equal 16, then you increment j plus plus. This is just a formula. We don't make it up. Only thing that you want to loop how many times. Okay? Then you have to open the bracket. Now, first one, that number plus plus. That means each one they counting, they increment one that number. So if the that number before they can be 4, then now the first one they will be 5, then 6 and 7, keep going. Okay? Otherwise, you cannot know what the that number. Second thing, you apply the end clock. Okay? However, in here, I said the first one they start counting. If they not, I want peak of U1, U2. However, when they start counting to number 2, 3, 4, 5, nothing wrong with U1. Only thing the counter is not counting right. So peak of will be U2. So that's why I'm using if statement. If j equal 1, then I want peak of to be U1, U2. Otherwise, else. Peak of will be U2. Now, if you're looking into here, you can see the number decimal and the height number. Number 1 in here, that means you want it 0, 8, 0, 1. And this 0, 8, 0, 2. However, if you're using the height for the output data, you cannot do in the loop. The computer only understands a binary. However, now they have to deal with a human. So anything they try to deal with you will be a decimal. Okay? Instead 0, 8, 0, 1, the same thing with number 1.
Yeah.
0, 2 with number 2, 3, 4, 5. Okay? So that's why I say for j equal 0. Okay? And j plus plus, that means j here. First thing j equal 1. You want output to be 1. J equal 2, output to be 2. Okay? And keep going. Only thing up to this one right here. When j equal 15, okay, then the output you don't want, after that, you don't want 16. Okay. The thing is, if you count, keep going, so they can be 15, 16. Okay. However, the output you want it to be 0. The thing is, the counter, when they reach 1, 1, 1, 1, and they go back to 0. So that's why we have to using few things here. Okay. Now, if j less than 16, that means j can be 15. 15 means 1, 1, 1, 1. I want the output expect data to be a j. J1 output 1, J2 output 2, J15 output 15. However, if j equals 16, you don't want output to be 16. You want output to go back to 0. So that's why I have to using the if statement here. I say if j less than 16, I say expected data equals j. Otherwise, else, I want expected data to be 0. Okay, then this is the same thing. Every program, okay, and you must close that, open here and close here. I say and for loop. Normally, the way to write the software using whatever they already done, okay, to using that and will be modified for different application. If you want for loop, then how you write for loop, okay?
Mr.
And
Pham, I
the
have a quick
question
question.
for the counting up.
I have a question real fast, Mr. Pham.
Yeah, go ahead.
Does what you just explained, does that work? Because so when you're counting up to 15,
Right,
that will be 1, 1, 1, 1 on your output.
right.
Does J become 16 or
No, J
greater?
15.
I'm sorry?
J will be 15, right?
Right, right.
Then if you up, you counting one more time. J now will be 16.
And so that will automatically flip the expected data to 0.
Right.
Okay,
But the output at that point, they not equal J anymore.
right.
Okay. I want J output to be 0. So that's why I'm using the if statement. If J less than 16, I want output to be saved at J. However, if they not less than 16, they equal 16. I don't want J expect data equal 16. I want expect data to be 0. Get along with that, the thing is you do a lot of testing for counter, up or down, or binary counter or BCD counter.
Mr. Pham, is there a reason that you leave J at the value it is instead of saying that you change the value of J to 0?
What I'm saying is when you J equal 16,
Finish.
that means you don't want output to be 16. The thing is for the rest of the counting here, I say output equal J. J1 output 1. J equal 2 output 2. J equal 15. Output will be 15. Okay. However, if J equal 16, output not 16. The thing is when output counter count up to 1, 1, 1, 1, then one more clock they go back to 0, not 16. So that's why you have to using the if statement. I say if J less than 16, 16. I want output supposed to be equal to J. However, when J equals 16, I don't want output to be 16, so that's why I say L, output to be 0. The thing on the loop here, you start the loop to say integer J equals J less than or equal 16. You keep increment. 1 to increment 2, 3, 4, 5. However, when you get a 15, you increment, they will be 16. And that's the output you want. Okay, any question about counting up? And now counting down, same thing. Okay, in here, you just follow, you can read and you try to understand. What do
Mr.
I
Pham,
mean?
they gotta put CO after count up
Right,
and then BO after count down.
right. That's what they're coming from the Excel. Only I try to help you to get the loop. Get along with the loop. The loop will be help, okay, for the guy to do the lab later. In here, if you read it, try to make sure you can follow it. I say, I start counting down, map data 0F, and on the step 21.1, I want to clear, okay? Step 1, write to port A 0, I30, okay? That means I want to set clear equal to 1 and load equal to 1. And next step, before you start counting from 15 down, you need to load 15. So I say write to port A, I set load 0, 1, 1, 1 here. That means I want to load. Output now will be 1, 1, 1, 1. However, after you loading, you want counting. You have to unload it. That means LD equals 0. And then you have to make sure LD must be equal to 1. 0 here, then they must be equal to 1. After you load it, output already 1, 1, 1, 1. Okay? If you not unload it, this still be 0. You cannot count. Okay? And now you can set it up. Okay? To write to what, whatever. I don't read it. Okay? A, clear 0, load 1, up, down, 1. And now you're using the loop. Okay? For J equals 15, you start from 15. Okay? If J greater than 0, then J minus minus. They're telling you, first thing, J equals 15. You apply the clock, they go to 14. You apply the clock, they go to 30. Okay, going down. So you must get the test number increment. Then you apply the clock. Only thing here, first thing counting down, you can say if J equals 15, P corp have to be U1, U2. Otherwise, P corp only U2. Okay. And now if J greater than 0, you want output to be J minus 1. Can you recognize that? At the beginning, okay? At the beginning, the output will be 1, 1, 1, 1, 50. When you apply the clock, 1, 1, 1, 0. They go 40. Okay. Now,
That's the
if
J
J
minus,
greater than 0, They say, I want expect data. J minus 1. Can you understand that?
That's what you just did by 15 down to 14.
Right. The thing is when you get the J equal 15, when you start countdown, they not equal, output not equal 15, they equal 14. So that's why expected data must be J minus what? 14. If J equal 14, they go down to 13. So 14 minus 1 to get 13. Okay. However, when you go down to 0, then the output is not 0. Output going back to 15. So that you can see countdown 15, 14, 13, so on. Go up to the get 0. They go back to 15. Okay. So that is how this software will be helping you. Okay, what I want you to do, complete Excel. I already modified the last one. Okay, make sure they pass. And when you coding, okay, you coding your program, okay, then you can upload it. Make sure no error. The thing is when you upload your program, Sam will be just run it, fail, first one, he stop, he don't care. Okay, and if you get a problem and you really don't know why it failed, you can Zoom with me just about 15 minutes. I can tell you what's wrong to get through it. Okay. We want one number 1, 2, 3, 4, 5, 6 have to be done before we keep moving on. Okay. The next lab I will be given to you 192, 74, 192.
The BCD
Exactly the
counter.
same binary. However, that will be BCD counter. Okay. That means the counting will be count 0 to 9 or 9 to 0. I want to give almost the same to see how many people can get through it. Build the circuit, run the test. That's easy. Okay. The key point is to try to understand. So when it fails, okay, then you're able to know how to fix it. I can give you an example here. Okay, now you already know what we're testing. I said I routed here. Okay, when you run the test, what do you think which test will be failed?
Counting up. The first time you're trying to count, it'll fail.
Yeah, just tell me. You know test 1, test 2, test 3, right? Test
Right.
1 will be load, test 2 load, test 3 will be clear or whatever. So when I routed this one.
Yeah, on your like he said, when you first start counting, because that has to do with counting. It don't have to do with loading or clearing.
Okay, all right.
That's 4.
That means the first test of the counting up will be fair. You see that?
Mm-hmm.
Okay, now, if I said I routed here, when you run the test, what test will be failed?
Counting up,
Counting up. Okay,
because down has to be held high for it to count up, right?
perfect. Yeah. So when I draw the here, what I want to telling you, I want to telling you is L1 not working. Why? The thing is when you measure right here, you want it to be a 1. However, we route it so you measure 0. So you measure 0 here, you know wrong. What you need? You have to go pin number 10. Make sure they will be 0. Okay? So if you get a 0 here, what can you tell me?
U1C is 40.
Right. U1C not working. You can tell U1C. Troubleshooting is what? You get a right output, but you get a wrong input, or you get a wrong output, but you get a right input. Then that part is not working. You see that? That is a troubleshooting. Especially when you're working, okay? They not, you have to test it more, but they not only one more. They can be get more, the same more, and the circuit board working and the other one not working. You cannot sit there and analyze everything in order to fix the problem. No, that's not the way. Have not enough time. Only thing that you can run this test with the good circuit board and measure what you think input on that file should be, what output should be, then you compare to your best circuitry. That is the way to isolate more easier. The thing that digital will be news for a lot of people. A lot of people just get along with the transistor and on DC, but everything now will be digital. Then you have to understand the digital. So you think you can upload everything on the test number 6. And also, a few more minutes, I can try to explain to you on this one here. Full adder here. That number 4. This is a full adder. You get a circuitry, one they call a half adder, and one you call a full adder. Okay? When you adding number here, 1 adding to 0, 1, right?
Yeah.
Or you get a 1 adding to 1. What you get?
0 carry the 1.
0 carry
Oops.
1. So basically, this is a half adder. You added only 2 numbers. Now, if you get a number here, 1, 0, 1, 1. Okay, you adding into 1, 1. Okay, 0, 1. Now, if you adding here, 1, 1 adding to 1 is here.
Zero.
Carry.
1.
Carry means adding 1 to next. 1 adding to 1 will be 0, 0.
0.
Carry 1.
1.
1, 0 is 1, 1, 0. Carry
1. 0 carry 1.
0 carry 1. 1 adding to 1, 0. 0 adding to 1, 1.
One.
Carry.
1, carry 1.
So this is we call a full adder.
Oh.
Okay? That means they adding also the carry. But this carry here, this carry here, they call a carry in.
In.
Okay? So basically you adding, you can getting PA, PA, pin 1, 2, 3. Pin 1A adding to B. And also you have to adding into C, E. Okay? And now, if you're looking on that pocket here, you adding 0, adding 0, adding 0, 0, 0. Okay?
Oh.
0 adding to 0. You get 0. 0 adding to 1.
1.
Carry.
1.
No carry.
Oh.
You don't have any carry.
Okay. Oh.
0 adding to 1. 1 adding to 0. You
One.
get a 1, no carry. Okay? When you get a 0 adding to 1, you get a 1. 1 adding to 1.
0.
Carry.
1.
You see that?
Oh, okay.
How you understand?
Yes, better.
Yeah, that is very easy.
So, Mr. Pham,
Yeah.
going back to DLAB06 then, and what we're talking about where if J equals less than 16, so when this carry out pin 12 goes high, that represents 16. Yes, and then that is what triggers it to go back to 0?
Okay, you say when J equals 16, right?
Right.
J equals 16. Then the output of the counter, you don't want 16, follow J. The thing is after 15, they must be returned to 0.
Right.
So that's why you get an if statement. If J greater than, let's see, if J equals 60, then you want output to be 0. That's what you need to using if statement. Okay, and when after the output get to the 1 and 1 and 1 and 1, so you already get the negative point coming out. That will be preset the flip-flop you want.
Thank you.
Okay,
Mr. Pham,
yet,
when I do my logic simulation, it asks me output is 3 state. What does that mean? It means 1, 0 or don't care?
now 3 statement high impedance.
Oh, thank you.
Okay, now I can give you the example quickly here. Normally, you can see this guy here look like that they call a buffer. If you get a 0 here, you suppose you get 0 here if this line must be round. Input, output the same. If you get 1 here, then you get 1 here. Okay? They're the same. That's what they call a buffer. If this line rounded. Now, why we need a buffer? I given to you example. You get input 2.4 volt. That will be a logic 1, right? You understand any voltage less than 0.8 will be 0. Okay? Higher than 2 volt, up to 5.5 volt, they will be logic 1. So 2.4 volt means logic 1. Then the output supposed to be logic 1. However, if you measure output, you can get 4.5 volt. They still 1. However, they increase more current and they want to get to the standard logic. It means output to be logic 1 U15 volt. Okay, so that's why they need the buffer. Input is 1 with a lower 1. However, when they go to the buffer, they bring it up to standard logic. That means close to the 5 volt. Okay, now that only happens if this line here round. Now, if not rounded, output they say high Z. That means our high output impedance. That only telling you when they go inside here, they get a big resistance inside. So they not allow any current coming out or coming in. So they can loading the bus. That is high Z, high input impedance. But we deal only with the logic. When we disable, that means this IC look like not there. Okay, so after you're done for this, you understand this two table here. That means you understand how the full adder working. I can give you one more before we stop it. Let's see. Now, this one, number 6. 1 adding to 0. You get 1. 1 adding to 1.
0.
You get 0. However, you get
Carry
carry 1.
Yeah.
Okay? And 1 adding to 1, you get 0. 0 adding 0, you get 0, but still carry
1.
Okay? 1 adding 1 is 0. 0 adding 1, you get a 1. And you get carry. Now you understand, right?
Yes, better this one.
Yeah, that's a very simple thing. Okay, so I hope you guys try to get as much at your DLAB. Okay, upload. So make sure he can verify on the lab will be good. Okay. I believe for, very short time, we're able to get to your lab. Okay. Only thing is they let the people get into the office. Okay. Then we can do it. Right now, nobody do anything. But that's a good time to really learn. Okay.
I don't think there's going to be anybody in the office until next year.
No, I don't think so. I believe they will be in the middle of the spring.
Yeah, that's next year, Mr. Pham.
No, no way. That everything up there, they will be done. Okay, school system now, they get a very big problem.
Right, that's right. They'll be back next year.
No budget.
Right.
The thing is they don't have money.
We don't have money either. So, hey, Mr. Pham, just convince yourself, man. They'll be back next summer or something.
That as you can see, I've been to the United States 45 years. This is the first time.
Wow.
This is the first time.
You better be careful, man. Watch out. Make sure they send you your paycheck. All right, Mr. Pham,
Any question? Anything?
that's it.
Okay, we'll see you guys next week. However, I want to make sure you understand. I already load the test yesterday on the handout.
Yes, I saw it.
Okay, you good. Okay,
we have
try to
to-
do again and upload again.
Okay.
However, after tomorrow, when you upload your report for the test, if you get 100 points, you only get C. Okay? That
Don't
means
worry, I won't get all 100.
if you upload late after you get the lab printed out already, then only C for part, okay? But not A or B.
Okay.
On A or B, only given to you on the U.
Okay.
So that's why I'm looking into that. I can recognize, okay, who good and who not really quite good. Okay?
Not good yesterday.
Not okay. Next time better.
Mr. Pham, you still want everyone to do it on the website and re-upload it again, correct?
Right,
Even though the best grade we can get this time is a C.
right.
Okay,
Guarantee you can pass.
so we'll just know that a C means an A.
Now, normally test on Tuesday. On Monday, I will go over most of them. Guarantee you can get C. Okay? Like yesterday, I can ask one question about the comparator when R1 open. I believe maybe the people don't know how to do. You see that? But I can tell you when the register R1 open, that means the op-amp now comparator now will be compared with 0. So output, they can be go to positive saturation or negative saturation. They not do anything, okay? Maximum. Look like they will be compared with 0. They not compare with the heterogeneous. Okay? Next week, Monday, I will be go through all of the 20 questions on the test, make sure clear for everyone.
Mr. Pham,
Also,
on that example that you just were talking about, sorry.
the thing that next week we'll be talking. I think we don't have a dead circuit here.
I was just going to say on the comparator circuit that you were just explaining where R1 is open,
Right,
that made the non-inverting input grounded, correct?
right. That
Right.
means they compare with 0.
Right. Thank you.
Okay. Okay, Monday, normally I will be go to the test we did this week and also review everything you need to prepare for the test on Tuesday. I telling you what part you have to go through. Okay, what I want to do, up to the point you get into Zoom, you can get A. That means you can do it right away. Okay, more and more will be helping you to get better. Okay, this is just the first time.
Do we have a test, other test on Tuesday again?
Yeah, Tuesday will be test number 2.
Oh my God.
Every week you get
Every week.
every
Oh
week
my God.
to the end. And also I telling you, every test I already given you the test bring out. Guarantee you get through that, keep that. Okay, when you get the job interview, that only one you can review. Otherwise, too many things. What you want to review?
Yes.
That's the only one. I believe I get 6 tests, 120 questions. When you look into the question, you can answer right away. That you can get more confident
Okay.
when you go to the test in the company. Otherwise, you review what? Too many things. Okay.
I really like that you're doing this. Thank you, Mr. Pham.
Yeah.
It's very, very helpful.
Yeah. The thing I already been get to it. I already been engineering for too many years. I know what the process for interview. Okay. And that's what I want to do. First thing, you know how to using the scope, how to using your meter, generator, that's a part of that. Okay. You don't have to know anything else. If you're working on the oscilloscope, no big deal. You can know right away what to do, then you're okay. Okay? Only thing is when you get a job, that email for me, then that's why I feel better. You know, this is a continuing education. So depend on individual. You're working hard. You understand. I guarantee you can get a technician job. Okay? They can pay you up to $25. And the job more skill. That's what would happen to some student in my class. They interview, they get a job, technician job right away. Okay. The thing is, I understand, she understand. So that's why not big deal. Okay. So anyway, we'll see you guys next week.
Mr.
Thank you,
Try
Mr.
to do
Pham.
try to get a lab done, the lab
Thank you, Mr. Pham.
you get. Yeah.
Mr. Pham,
Yeah.
I just want to clarify the download, the test, e-test 1 that we did yesterday. So
Right.
we're going to download the question, we're going to redo it and fill it up on the e-test 1 for 2020 report again,
Right.
and then upload it again.
Right. The thing is, Sam will be know when you upload.
Okay, so if we upload again, wouldn't that overwrite what we did uploaded yesterday?
I don't think so.
No,
Because
because we've
same
we've
thing.
uploaded multiple versions of the same
Yeah.
assignment before.
Yeah, you upload, they just get it, they don't care, you know, it's what inside already or not.
Oh, okay, so it wouldn't overwrite what
Yeah.
we uploaded yesterday.
But the same when he take it out, he know you upload on the Zoom day or you upload on after that few days.
Okay.
So they can, you get 100, they given you C.
Okay. All right, thank you.
Okay, you are welcome. Get good enough.
Thank you. Have a good night.
You too. Okay, on to your guy. Okay, bye.
All right.
Bye bye.
Thank you.
Bye.